All right, guys, good morning. Welcome to another wonderful lesson in the world of 8th grade mathematics. Today we're going to be covering the difference between linear and nonlinear functions. So we just got done with Unit 5, which covered linear equations. And a lot of times students ask, what's the difference between an equation and a function? And so when you think about this, so equations are an algebraic representation of a function relationship. All right, so the function relationship would basically just be describing how one thing is related to another, and an equation is a way of visualizing or showing that relationship. So when we say function, we're talking about a broader term, okay? We could display a function relationship using an equation, or we could display a function using a graph or a table. Okay, so when it comes to linear versus nonlinear functions, the names kind of describe it for you. When we're talking about a linear function, we're talking about a straight line. Okay. With linear functions, we see a constant rate of change, meaning that the function is changing by the same amounts all the time, okay? So it's always increasing by the same amount. The other word for this would be slope. So we have a constant slope, okay? Also, with linear functions, the x does not have an exponent. All right, and what we mean by that is the x variable never has an exponent. All right, so there's no exponents with linear functions. And then finally, with linear functions, we always can rewrite in slope-intercept form, which is y equals mx plus b. So this relates directly to what we just covered in Unit 5, okay? Now, on the other side of the paper, we have nonlinear functions. So with nonlinear functions, the function does not produce a straight line, so not a straight line. So on a graph, let's just do this real quick. So on a graph, we might see, so we'll make one for linear and nonlinear. So for linear functions, it looks like a straight line that can be, going up. So we might have a straight line like this. We can also have, a vertical line, right? We can also have a horizontal line, or we can have a negative slope line as well. So any of these would be examples of linear functions, right? With a nonlinear function, we're going to see like a curved line. So maybe something like this, all right? Or we might see, a wavy line, something like that, right? Like we can see all different types of lines, like maybe a horseshoe. These are all examples of nonlinear functions because they don't produce a straight line, okay? A linear function does not have a constant rate of change or slope. All right, and what this means is that the amount it's changing by is always changing. Okay, it's not constant. All right, typically with nonlinear functions, x has an exponent or is the denominator of a fraction. So, examples of this, if you see an equation that says y equals x squared, this is a nonlinear function because the x has an exponent. Or if you see an equation such as y equals x divided by, not x divided by, excuse me. If we see an equation that says y equals 5 divided by x, if x is the denominator, then this is a nonlinear function. It's not going to produce a straight line, okay? So finally, you cannot rewrite in slope-intercept form with nonlinear functions. So y equals mx plus b is not going to work here. All right, so that's what we got on the first page. When you produce your foldable here, these two pages just simply fold over, and it makes like a double door foldable. Okay, so we're going to start at the top of the page here. So this first section is, these are examples of linear functions. And so what we want to do here is figure out what identifies these three examples as linear. So the easiest example is going to be the graph, because the graph, if we have a line that's straight, so this is a straight line, and it doesn't matter if it's vertical, horizontal, or diagonal, just as long as it's straight, we know this is a linear function. So because it's straight, it's linear. Okay? So easy peasy. Like if your line is curved in any way, or if it has multiple sections or multiple straight sections, but they're not all the same, it's not linear. Okay, so the table is a little more challenging, because in a table we got to do a little bit of legwork to see if it's linear. So the main thing about this is, does it have, and actually let me rewrite this somewhere else. So the main thing is, does the table, does it have a constant rate of change or constant slope? So the way we answer this question is we need to see how x is changing and how y is changing, and it's got to be consistent. So we look at how x is changing first, so that's plus 3. And then we have plus 3 again, and then we have plus 3 again. So that x change is consistent, but the y change also has to be consistent. So here we have minus 8 again, and minus 8 again. So our slope, it has a constant rate of change because it's changing consistently, and that slope would be negative 8 over 3, and that would be the slope. So therefore, this is a linear function. Check. Okay. All right, so like I said, the graph's easy. Table's a little bit more challenging. Now let's talk about the equation. So how do we know if this equation is linear? So the main thing is, can this equation be rewritten in slope-intercept form? All right, and so remember that slope-intercept form is y equals mx plus b. So I want to do a little bit of work here to get rid of the parentheses and see if this can be rewritten in slope-intercept form. So to get rid of the parentheses, I'm going to distribute, because that's what that 4 is doing. So I'm going to distribute to everything in the parentheses. I get y equals 4x minus 4. So this is in slope-intercept form, y equals mx plus b. So therefore, this is linear. I'll show you some more examples here in a little bit to show you what this looks like when it's nonlinear. All right, so linear, linear, and linear. Okay, so let's talk about the nonlinear versions. So the graph, again, easy. All right, this is a curved line, or it's not straight. So this line is not a straight line. So therefore, this function is nonlinear. Okay, so the graphs are easy. All right, what about the table? Okay, remember the question we ask ourselves for the table is, does this have a constant rate of change? So let's look. So we've got, for the x change, we've got plus 2. Then we have plus 2 again. Then we have plus 2 again. So that's good. All right, the x is changing consistently. Let's look at the y. So the y changes by plus 9, then by plus 22, and then by like plus 55. So this is not consistent down here. So the slope, or what it's changing by, is not consistent. Therefore, it is non-linear. Now, there were two things that we talked about on the first page to look for with equations. If x has an exponent, or if x is the denominator of a fraction, then your equation is nonlinear. So right here, because x is the denominator of this fraction, that means this equation is nonlinear. Ooh, what happened? That means this equation is nonlinear because we can't write this in y equals mx plus b, okay? So x was the denominator, so that was the problem. If x also has a variable, no good, all right? So some easy identifiers for linear versus nonlinear. Let's take a look. So then this last section is deciding whether the following graphs, tables, or equations are examples of linear or nonlinear. So let's start with the table. Sorry, my screen's going a little wonky here. All right, so again, when you're dealing with the table, we've got to see if the rate of change is constant. So let's take a look. All right, so let's take a look at our x changes first. This is a vertical table this time. So we've got plus 2, plus 2, plus 2. So that looks good. Let's take a look at y. So 8 minus 4 is 4, so we're subtracting 4, subtracting 4 again, and subtracting 4 again. So this table has a constant rate of change, or constant slope. So therefore, this table is linear. If we were to graph these points on a line, we would see a straight, or if we were to graph these points on a coordinate plane, we would see a straight line. Okay, so the next one, easy. The graph, we see a curved line. It's not straight, so therefore we have a non-linear function represented in this graph. All right. So let's look at these equations. So with the equation, remember, if x has an exponent, all right, that means this equation is nonlinear because x had an exponent. If you see x squared, x to the third power, x to the fourth power, that's nonlinear all day long. Doesn't matter what the rest of the equation looks like. Okay, so then we have an equation here in standard form. If we can rewrite this in slope-intercept form, then it's a linear equation. So let's try to solve for y here. So we're going to subtract 2x from both sides to solve for y. Okay, so we get 3y equals negative 2x plus 7. I'm going to divide by 3 to finish it up. And I'm going to write it over here, y equals negative 2/3 times x plus 7/3. This is in slope-intercept form. Therefore, this equation is linear. Okay? So the main thing is I noticed that x was not a denominator anywhere, and there were no exponents attached to the x variable. So right off the bat, I could tell this was a linear equation. Okay? And then finally, the last one, this is in slope-intercept form. Y equals mx plus b. So therefore, this is a linear relationship. All right, so let's try the table again. If you'd like to pause the video and try these two on your own, go ahead. Otherwise, we're going to keep going. I need to make a little room for myself here. So again, what we're trying to do here is with the table, we're gonna look for a constant rate of change. So for the first y change, we see -5, -5 again, minus 5 again. So the y's are good, constant change. For the x, we see plus 7 again, and plus 7 a third time. So our slope would be the change in y over the change in x. It's constant every time, so therefore this is a linear relationship. The next one, we see a straight line. Okay, doesn't matter if it's positive or negative or vertical or horizontal. It's a straight line, so therefore it is linear. All right, a couple more. So if you haven't tried a table yet on your own, go ahead and pause the video and try this one. All right, I hope this is recording. Hopefully so. So we've got a table here. So we're going to look for a constant rate of change. We've got to look at every single one of them. So we got plus 3, plus 3, plus 3. All right, on the bottom for y, we've got plus 3 also. 7 plus 5 is 12, and 12 plus 7 is 19. So this is not constant. So therefore, this table would be a nonlinear relationship. All right, moving on. So looking at this equation, I see that x has a variable, and it's also a denominator of a fraction. So sorry, I said x has a exponent and it's also a denominator. Okay, so because it has an exponent, or because it is a denominator of a fraction, that means that this function would graph a non-linear relationship. All right, last one, I think. Yep, last one. So, table, easy. Just look at the change. You got to look at every single one of them. So we got plus 1, plus 1, plus 1. So that checks out. On the bottom, plus 1 for y, plus 1 for y, plus 1 for y. So everything is constant. Therefore, this is a linear relationship. And our slope would be the change in y over the change in x. So it would be 1. So that's this lesson in a nutshell. Easy, right? Now you know how to identify linear relationships and nonlinear relationships in all three forms using a graph, table, or equation. All right, let us know if you need help.